Okay, question number 3. You have this. First thing you have to check the determinancy. So for the first one, you have 2, 1, 1, so you have 4. And you only have one part. So 4 minus 3 is equal to 1. So you can just use the moment to find all the reactions. So you have to because it's first degree indeterminate. So you have to remove one reactions. So I choose the middle one. After you remove it, make sure you check if the beam is stable or not. You have a pin, you have a roller, so simple supported beam, so it's good. For the unit load, since we removed the y-axis, so you have to put a 1 here, because you remove it, you have to put it back here. So for this one, after that, first step, you pick a redundance, and then for unit load, you just put it back. Second step, find the reactions. You take a moment at this point, you can find the y-axis at this point, and then you just take the sum of the y-axis to find this reaction. So if you do that, you're going to have 22.8 or 22.2. And for this one, you're going to have 16.8 for x-axis 0. And for this one is 20. Is that 20?
Yes.
This one is 30. So you're going to have 0.6, 0.4. Step 3, draw the shear moment diagram. So draw the shear first. So you're going to have going up 22.2. Go to here, bring it back, go to here, bring it down, go to here, bring it down again, come to here, and it's 0. So this one is 10.2, negative 1.8, 1.8, yes, negative 16.8, 0. And for moment, you're gonna have this area, so you're gonna get 133.2, and then you plus this area, you're gonna get too much, 214.8. Then minus this area, you're gonna get 168. And then minus this area, you're going to end up as 0. So this is your moment diagram. And for this one, same thing. You draw the shear 0.6, 0.4, and a 0. And for moment, this area, this is negative 12. So after you find the moment diagram, you can use this this table in the front of the page or back of the page. I don't know. Just find it. This one. So for the first part, you're going to have a table. Let me just show the table. This card I call it it delta, because this one is A, this is B, this is C. So this thing is B, so I call it delta B. And this one is FBB. So for this one, we're going to use for the first part. For the first part, we have no distance. Here's 6, here's 8, here to here is 26, here to here is 10. Okay. Yes. So here to here, 6, here to here is 8, here to here, 26, and here to here.
Could you label what's the reflective shape and moment and so on?
What?
There's only bending and moment.
That's shear, okay.
Shear?
Shear and moment.
Okay.
Shear moment, shear moment.
Not pay attention.
It's the bar.
So first for delta B, you choose this area. It's a triangle. And you come to here. You do the same thing for 6 feet. So you draw 6 feet right here. Here is 20, so 6 should be right here. 6 feet. You draw 6 feet, you find this point. A similar, how do you call that?
Similar triangle?
Similar triangle. This over this, so you, because you have negative 12 here, so this over this is equal to this over this, so you can find this point. You're going to have negative 3.6. So you compare this triangle to this triangle. This to this. So you go to the table. Triangle, triangle. So you come to here. So you're going to use this formula. So you're going to have, for the first one, you're going to use this formula. 1 over 3, big M, small m, L. So for this one, you're going to have, for the L, 6 is your L, because L never changed, so 6 is your L. For this one, I hope you can see it. This is called M, big M, sorry.
If they can't see
Big
it, they can
M.
hear it.
This is your L. So L is equal to 6, M is equal to 133.2. For this one, L is equal to 6, small m. Because you know the difference between big M and small m is, this is real number, small m is unilow number. So for this one, you're going to have 1 over 3, big M is how much? 133.2 times small m is negative. So negative 3.6 times L is 6. So you're going to get negative 959.04. So second one, you're going to use this area. The A feet. A feet is going to be 4, 12, so 6, 8 right here. Do the same thing, similar triangle. This over this is equal to this over this. So you're going to have negative 8.4 and put this here. So for this one, same thing, go back here. You're gonna have trapezoid and trapezoid. So you're gonna bring up to here. So you're gonna use this formula. So you're gonna use this formula. 1/6. Small m. Small m1, I'm sorry. Times 2 times big M1 plus big M2 plus small m2 times M1 plus 2 big M2 times L. Long formula. So for trapezoid, this is going to be your big M1. This is going to be your big M2. The L should be the L should be 8. And for this one, same thing. Small M1, big M1, or big M2, or small M2. I'm sorry. Small M2, and the L is 20. L is 8. I'm sorry, not 20. So you do the same thing, just plug in numbers. 1/6. Small m1 is negative 3.6 times 2 times big M1. Big M1 is 133.2 plus big M2 214.8. 214.8 plus small m2 negative 8.4 times big M1 133.2 plus 2 times big M2 214.8 times L. L is 8. So you do that, you're going to get negative A1 or A613.12. For number 3, it is this big trapezoid. But the point is, this is trapezoid. But this, it should be start from 20 to this one, 26, so it's 20, 26. I'm sorry, no. 14, 26, and 10. So for this one, it should be start from here to here. So let's draw the 10. 10 should be right here. This 10. You're going to use this. This is not a trapezoid and it's not a triangle. So according to this table, nothing look like that. You only have trapezoid and trapezoid. So in that case, we have, in this case, we have to cut it into 2 pieces. We have to cut it. So right now we're going to have a trapezoid and a trapezoid. So if you do that, you cut it at 20. So you make a cut at 20. Here's to here is 14. So we have is 6 over here. 14, 14. Yeah, you have a 6 over here. So you can have this little piece over here. You do that. Use the so you have to find this triangle over here. It's a little tricky. You use this triangle to find the similar triangle. So this over this is equal to this over this. If you do that, you're going to find this point equal to 204. So right now, you have to use this trapezoid and this trapezoid. So do that. Because it's trapezoid and trapezoid, so same equation is not going to change. So you're going to have, I'm just going to write numbers. 1 over 6 negative 8.4 times 2 times 204 plus 214.8 plus negative 12, negative 12? Oh yeah, negative 12 at this point. Negative 12 times 204 plus 2 times 214.8 times the length is 6. So you're going to have 128.
Then you can solve it. I can solve it too.
And then you're done with that, so the next one you're gonna have, damn, I don't know what to draw now. Okay. You're gonna have this and this. Okay, I should use black right here. Same thing here, we have trapezoid and trapezoid, so same equation. This equation again. So you're gonna have, oh my god, 1 over 6 negative 4 times 2 times 168 plus 204 plus negative 12 times 168 plus 2 times 204 times 20. The length this time is here to here, which is 20. 80 is here to here. So 80 minus 10 is equal to 20. Same thing here, 20. So you're going to have negative 30240. And the last one. Last one is a triangle. So triangle and triangle, you use the same one as the first one. So this formula. So you're going to have 1 over 3 times big M. Big M is 168 times small m. Small m is, oh, I didn't write it down. You use the similar triangle, you're going to get this one is negative 4. So times negative 4 times L. The length is 10. So times 10. So you're going to get negative 2240. And you add this, and this up. You're going to get negative 54886.88. And for FBB, so for FBB it's easier. I should bring it back here. For FBB, you only look at the unit loads. So you're going to have 2 parts. 1 triangle and 2 triangle. So for triangle, for FBB it's easier because for this one, you only have to take the area if you have a triangle. You just take triangle times 2. So in this case, is triangle to triangle for this one. And for this one, same thing. Triangle times triangle. You use the same formula. But instead of big M times small m times L, we just take small m squared times L. So if you do that, you're going to have, this formula is going to change to be small m times L. So you're going to have 1 over 3 times small m, which is negative 12, times negative 12 again, times the length is 20 for the first one. So you're going to have 960. And for the second one, we use the same formula again. 1 over 3 times small m is 12. So it's 12, negative 12 times negative 12. The length this time is 30, because here to here is 20, here to here is 30. So you're going to have 1440. You take this, you add this and this, you're going to have 2400. And this is for FBB, and this is for WB. So if you have this, you have to go back to the formula. Before we have a roller here, but you remove it, so you're going to have a deflection like this. So I assume this one going down is positive. So that's why I have, is that how you say it? This one reflect, turn clockwise. So you're going to have delta B. Yeah, going down is positive. So you're going to have this one is going up, but I assume going down is positive. So in this case, it's going to be negative By, because By creates this kind of force going up. So By times FBB is equal to 0, because before you have a roller here, it's not going to move, it's not going to deflect. So this is your equation. So now we have WB and FBB. We can find FB or By. I'm sorry. So let me erase this. So you're gonna have negative 54,886.88 plus minus By times 2400 is equal to 0. Bring this to that side, become positive, but you have negative, so become negative. So negative divided by 24, so it's going to be negative 229. But like I said, it's negative. That means going down is positive, so going up is negative. So this is going up. Right? Can you stop it for now? Sorry, I made a little mistake. This one, why WB is positive is because if it deflect this way, you're putting down is clockwise. That's why you have positive. But this one, if you have force acting up, it's going to create this kind of deflection. So it's clockwise, counterclockwise. That's why it's negative. So, let me get it make sense. So this one is gonna be no, I mean I'm assume going up is positive. So you have this at this. So you're gonna have, since it's positive. So when you bring the negative side to the zero, it becomes positive. So positive divided by positive, so it's going to be positive. And like I said before, going up is positive, going up is positive. So this one is going up. So we have Vy is 22.9. So after you find the force, I can erase it, right?
You erase.
After you find By, you put it back here. By is 22.9. So you put it back here, you erase the old one. Then you do the moment again. So you're going to find this reaction and this reactions. So you're going to have the new reactions. 8.46 kip, 7.64 kip. So now we have all the force. You can draw your shear moment diagram for shear. Going up 8.46, going down to negative 3.54, and come to here, go up, down again, so it becomes negative 15.54. Bring it up to 7.36. Bring it down. So negative 7.64. That's 0. Here's 6, 8, 6. 20, 10. So for moment, positive area, so you're going to have something like this. Linear. 50.76. Negative area is going to drop to 22.44. And then it drops again to negative 70.8, then come up. $76.4, and then drop to 0. So now we have moment, we have shear, we have moment. So we're going to have deflection. For deflection, this is positive, negative, positive. So you have smile face, sad face, and smile face. So how are you going to do that? So first draw your sad face, so you know it's going to look like this. Sad face. And this is your support. This point is sad face. So at this point, you start being sad face. It's going to be smile face, then becomes sad face, and here sad face, then turn smile face, like that. So we're done with number 3. So that's it.